Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present on Cayley's Theorem. But first, let me introduce you to our team, which is the first one is me, Nur SYAFIQA binti SHAMSUL, and Nur NATASHA binti CHAILAN. So the theorem that we chose is Cayley's Theorem, where every group is isomorphic to a group of permutations.
Next, for proof, let G be any group. The left regular representation provide a map phi of G mapping onto permutation of G defined by phi x equals to lambda x. We must verify that phi is a group homomorphism and that phi is 1-to-1. So first, for 1-to-1, suppose that AB element of G and phi A equals to phi B. Then lambda A and lambda B. Lambda AE equals to lambda BE. For lambda A, we will get A and lambda B will be B. Then we will get AE equals to BE. And by properties of identity, we will get A equals to B. Thus, phi is 1-to-1. Second, for homomorphism, let A be element of G, then phi AB equals to lambda AB, and phi A times phi B equals to lambda A times lambda B. Lambda ABG equals to AB times G, and by associative properties, we will get A times BG. And by definition, we know that A equals to lambda A and B equals to lambda B. Then we will get lambda A times lambda B times G. So, lambda AB equals to lambda A times lambda B, which implies phi AB equals to phi A times phi B. Thus, phi is homomorphism.
So the corollary here says that if G is a finite group of order n, then there is a subgroup of H of symmetric group of n letters such that G is isomorphic to H. So for example 1, consider the Cayley table of group integer modulo 5, which is the element is 0, 1, 2, 3, and 4. So this is the Cayley table of group integer modulo 5. Guided by the proof of Cayley's theorem, we define that H is the element of theta 1, theta 2, theta 3, theta 4, and theta 5. From the question, the function of group integer modulo 5 mapping onto the symmetric group of integer modulo 5 is equal to symmetric group of order 5, where the function x is equals to lambda x, and the operation is lambda xg is equals to x addition modulo 5g, where g is in group G. So the first one is theta 1. So the operation here is x addition modulo 5, 0. And the answer we obtained here is iota, since all of the elements maps to themselves. So the next one is iota theta 2, where the operation is x addition modulo 5, 1. Where 0 mapping to 1, 1 mapping to 2, 2 mapping to 3, 3 mapping to 4, and 4 mapping to 0. And the answer here is the cycle notation of 1, to 2, to 3, to 4, to 0. The next one is theta 3, where the operation here is x addition modulo 5, 2, where 0 mapping to 2, 2 mapping to 4, 4 mapping to 1, 1 mapping to 3, and 3 mapping to 0. And the answer we obtain here is the cycle notation of 2 to 4 to 1 to 3 to 0. So the next one is theta 4, where the operation for lambda x3 is equals to x addition modulo 5, 3, where 0 mapping to 3, 3 mapping to 1, 1 mapping to 4, 4 mapping to 2, and 2 mapping to 0. And the answer we obtained here is the cycle notation of 3, 1, 4, 2, and 0. And the last one here is theta 5, where the operation for lambda x4 is equals to x addition modulo 4, where 0 mapping to 4, 4 mapping to 3, 3 mapping to 2, 2 mapping to 1, and 1 mapping to 0. And the answer is the cycle notation of 4, 3, 2, 1, and 0. Thus, H contains the element of iota, the cycle notation of 1, 2, 3, 4, and 0, the cycle notation of 2, 4, 1, 3, 0, and the cycle notation of 3, 1, 4, 2, 0, and the last one is the cycle notation of 4, 3, 2, 1, 0. And therefore, the group integer modulo 5 is isomorphic to the subgroup of H.
For example 2, show that group U12 multiplication modulo 12 is isomorphic to a group of permutation. The elements of U12 are 1, 5, 7, and 11. Phi of U12 implies symmetric group of U12 equals to symmetric group of 11. Phi x equals to lambda x, and lambda xg equals to x multiplication modulo 12 g. G elements of U12. Lambda x1 equals to x multiplication modulo 12 1, we will get iota. And lambda x5 equals to x multiplication modulo 12 5, we will get cycle notation 1575. Lambda x7 equals to x multiplication modulo 12 7, we will get cycle notation 17,5,11. And lambda x11 equals to x multiplication modulo 12 11, we will get cycle notation 111,5,7. Subgroup H contains the elements of iota 15, 7, 11, 17, 5, 11, 1, 11, and 5, 7. Therefore, U12 is isomorphic to the subgroup H.